All right. Good afternoon. After looking at 5E Part 2 and doing some of that, I wanted to continue with these quadratics with imaginary roots and continue with this. And I want to give you guys some of them that were a little more friendly, a little bit more clean. And I sort of wanted to show you how these things, we could find the roots and they can work forward and backward. Okay. Now, remember, if the roots are imaginary numbers, or if the roots, you know, are if they don't exist, really what they are is they're complex numbers. There's a real number component and an imaginary part. Okay, so all these roots, if we were to do the you know, quadratic formula and find the roots, if we were to get imaginary roots, what we would have is a plus or minus bi of some kind. Okay, so the two roots become a plus bi or a minus bi. Okay, which really sets x equal to a plus bi or a minus bi. Those are our two x values. Now remember, a root occurs when the graph hits zero. Okay, so when the graph hits zero, there's roots. Now again, this graph doesn't hit zero on the x-axis because they're imaginary, but we still have two imaginary roots. Okay, and the two imaginary roots are conjugates of each other. So, here could be our a minus bi, and here could be our a plus bi. Again, they're imaginary, so they don't really exist. But if we work them back forwards, we could still put the equation back together. So basically, what we're going to sort of do here is take the equation apart, factor it out, and put it back together. Okay. There's four problems on this. I'm going to do the first one right here, and I'm going to have you guys do the last three on your own. Okay. Now, when we factor these things out, what we end up with, okay, if x is equal to a plus bi, remember that sets a thing equal to zero. Okay, so x minus parentheses a plus bi is equal to zero, or um, x minus parentheses a minus bi is equal to zero. Okay, same thing that we have if we have a quadratic thing and we factor it out and we get it x plus 4 and then x minus 3, right? If we factor that out and you get x plus 4 and x minus 3, okay, the roots are x equals negative 4, x equals positive 3, right? As we set each of these things equal to 0. The same thing applies here, okay? So this thing really factors out into x minus parentheses a plus bi times x minus parentheses a minus bi. Okay, so it's going to factor out. It's going to factor out into something like this. Okay, and then we're going to distribute those things back through. It's going to be a little bit complex, but it'll clean up um, because we're not going to have any imaginary numbers once we redistribute back, and it should give us our original equation that we had in the first place. So without further ado, let's do this first one here together. All right, so we have our quadratic formula. Okay, so negative b. Okay, a is 1, b is negative 4, c is 13. Okay, so negative b, which is 4, plus or minus square root b squared, which is 16, minus 4 ac all over 2a. A is 1, so over 2. The discriminant inside that root, okay, it's going to be 16 minus 52. Okay, 16 minus 52 should give us negative 36. All right, so as we do our quadratic formula here, we simplify the discriminant. 16 minus 4 times 1 times 13. So we get 4 plus or minus the square root of negative 36 over 2. Okay? We could break this thing down if we want to into the square root of negative 1 times 6 times 6. And the whole square root thing can go away. Okay? So the -1 can come out here as I, just because the square root of -1 is I. And 6 times 6 is 36, so the square root of 36 is 6. So that square root of -36 really becomes 6i. Okay, so 6i can fill in for our square root of -36. So we have 4 plus or minus 6i divided by 2. What we can even do to simplify this down is we know that 4 divides by 2 and 6 divides by 2. So we can do 4 divided by 2 to get 2 and 6 divided by 2 to get 3. So if we divide by 2 and divide by 2, what we really end up with is 2 plus or minus 3i. Okay? And all the quadratics, the last 3, are going to simplify nice and pretty to something like this. They're not going to be big old fractions and decimals and stuff like we saw in the past. Okay? The very last one here is gonna have a decimal, but they're gonna be nice and clean. And so those will have decimals, but numbers 2 and 3 will be nice, clean, whole problems here. Okay, so I lost my illustrations here. So 2 plus 3i, 2 plus or minus 3i are our 2 roots. Okay, so really our roots are x is going to equal 2 plus 3i, or x is going to equal 2 minus 3i. Because again, we split this bad boy up right here. 2 plus or minus 3i is 2 plus 3i, or 2 minus 3i. It's both. All right. So now we're going to rewrite these as, x minus a plus bi times x minus a minus bi. Okay? Because again, if x equals 2 plus 3i, then x minus 2 plus 3i has to equal 0. And ditto with the other one. Okay? So 2 plus 3i and 2 minus 3i are our roots. So here we have x minus 2 plus 3i. And we're going to multiply that by x minus 2 minus 3i. Now, not going to lie, it's a lot there. All right, there's a lot here, but we can really clean this up pretty nicely. All right, we can really clean this thing up pretty nicely as we sort of go through this thing here. All right, so let's go ahead and distribute. Okay, the x is going to multiply with the x. That's going to give us x squared. Okay, the x is going to distribute through the -2 and the positive 3i. So the x here is distributing with -2, so that'll be a minus 2x. Now we have a positive 3i because we have a negative 3i. So the x is going to distribute to a positive 3i. So it's going to add 3ix. Before we start panicking here, let's just finish this problem out. Okay, so we distributed this x through both of these things. Now we got to distribute the 2 plus 3i into these things. Okay, we have a -2 right here. Okay, so we have a -2 multiplying by this x, so that'll be minus 2x. and we have a negative 3i, okay, a negative 3i distributing through this x. So that's going to minus 3ix. All right. Now we have to distribute this complex number through its conjugate over here. Okay, so we distributed the 2 to the x and the 3i to the x. All right. Now we got to distribute the 2 to the 2 and the 2 to the 3i and the 3i and the 3i and the 3i and a 2. Okay. So this is where it gets a little interesting. So I'm going to do this in purple here just so I combine the red and the blue. So the 2, that's a negative 2 distributing to a negative 2, so that gives us a positive 4. The negative 2, excuse me, is going to distribute to the positive, is a negative 3i. That's going to give us a 6i. Or negative, let's see. Negative 2 times a positive 3i, that's going to be a minus 6i. Okay. Now we have a negative 3i. Okay, this 3i is positive with a negative distributing to. So we have a negative 3i to the negative 2, which gives us plus 6i. And lastly, we have negative 3i times a negative 3i. Okay, so negative 3i times a positive 3i. Negative 3i times a positive 3i is going to be a negative 9i squared. It looks like a lot. Just take your time. No rush. Now, we should see anything with an I is going to cancel out. Okay? So, positive 3ix, negative 3ix, gone. Negative 6i, positive 6i, gone. Okay? Now we have negative 9i squared. Okay? Remember, what's I squared? I squared is negative 1. Okay? So negative 9 times I squared, really negative 9 times negative 1, which is positive 9. So let's combine some like terms down here, shall we? We have x squared. We have negative 2x minus 2x. So negative 2x minus 2x is negative 4x. All right. Then we have plus 4 here, plus 9 there. So what does that become? All right, well, x squared minus 4x plus 13, which was our original thing right there. Okay, so basically we took our original thing, our original quadratic, we factored it. We factored it into where it looked like this, and we had two complex roots, two complex imaginary roots. Okay, 2 plus 3i, 2 minus 3i. We wrote it like this accordingly because that's how it is when it's factored out. We distributed everything through and sort of put it back together, combined like terms, where it was put back together into our original equation. I made these ones a little bit easier to do than on part 2. So part 2, you just focus on getting the roots. Part 3, I want you guys to try getting the roots and then putting them back together. Okay, that's what I want you guys to do on these notes. Let me know if you have any questions. These things should end up being pretty nice and clean and neat, and shouldn't have too much of a mess on it. But if you get stuck, let me know. Take care.